how are you guys doing? So in the previous video, we went through the very basics of using geometry nodes and the attributes specifically. And in this video, we're going to go a bit deeper into it and make this effect that you can see here. If you have never used geometry nodes or you didn't watch my previous video, you might want to go watch that first and then come back to this, because I won't repeat all the information from the first video regarding the attributes specifically. Without any further ado, let's get straight into the tutorial. Okay, so again, first of all, you need to go to builder.blender.org and then download this latest 2.93 alpha build from here to have all the latest features. And then once you open that up, you can start working on the effect. The scene will be very minimalistic. We'll leave this default cube here, move it up a bit, and then we'll add the Suzanne monkey from here. Move that up a bit also, rotate it along the x-axis to make it look like it's sitting on the thing there. Maybe we'll make this a little bit wider. Something like this. And let's go to the modifiers for the Suzanne object. So we'll go here and we'll add a subdivision surface and we'll increase the levels a bit so that we have a smoother geometry here. You can click to select this modifier and press Ctrl A to apply the modifier. So now we have the geometry here in the edit mode also. And then we'll add another modifier, and that will be the geometry nodes modifier that we also used in the previous video. And again, it automatically created a node group for us. So we can just drag a new window from here and go to the geometry node editor here. And here we have the automatically created node group. The geometry is going straight from the input to the output. Nothing's happening, and we still have the Suzanne here. Let's move this out of the way. Press N here to move those out of the way. And now we get to work on the actual effect. So Shift A to add nodes. Point distribute is the first node we're going to add. Just drop it here. And you can see that we have some points scattered around here. And if we increase the density, you can see that the points are scattered on the Suzanne mesh. But you can see that the point distribute node works so that it hides the original geometry and shows only the points that are being generated. And that's the first thing we're going to fix. So we'll just make some more space here. Shift A, geometry, join geometry from here. And what this node does is it takes two geometry inputs and combines them and then outputs a combined geometry to the outputs. So this geometry data type is just a collection of faces, vertices, points, attributes, everything that's going on inside the modifier. They are all dumped into this geometry flow here. And so this join geometry node can take many kinds of geometry and sort of blend them into one combined geometry. So what we're going to do is we're going to move this out of the way and just take the input geometry, which was the mesh before the point distribute node was added. So we take this original geometry and feed it to the join geometry node. So now we have the Suzanne mesh and also the distributed points. These points that you see here in the viewport don't actually have any visible geometry. If you switch to the rendered view and hide the overlays, you can see that we don't actually have any points here. So we have to make a separate object that we're going to instance on the place of the points here. So I'll add another object here, mesh torus, and we can specify the amount of geometry we want from this submenu here. We'll use 6 for both the major segments and the minor segments. And then I'll also decrease the minor radius a bit to make it thinner. Let's also make it a lot smaller, something like this maybe. And so now we have an object that we can use here in the geometry nodes. So let's just make some space here and let's add a point instance node from here. And we'll instance the points before we join the geometry at the end there. And we can just specify an object for this point instance node and it'll be the torus we just created. And now we already have some nice looking things happening here. You can see that the points actually automatically align themselves to the mesh they are generated on, which is very nice. And then we can just increase the density to make it look more busy. But now you can see that we have a problem because a lot of these points are overlapping. So we get this not very nice looking overlapping geometry here. But luckily the developers have already thought of a solution here. All you have to do is change this random scattering mode to the poison disk mode, which gives us one extra parameter here, distance minimum. And what this does is it sets a minimum distance that the points can be from each other so that they don't overlap. So if I slowly increase this, you can see that the points are starting to get away from each other to retain a custom minimum distance, which is very nice. I think 0.05 is actually a good value. And then we can just increase the maximum density really high to make sure that every possible space is used for a point. And that already looks very nice. So now we can make the appearing and disappearing by proximity effect. And for that, I'm going to add an empty object, a sphere. Then we'll go back to the nodes here. And now we get to the attribute stuff. So again, if you haven't seen my previous video or you've never used this attribute stuff, definitely go watch that video first and then come back to this video. So we will use this attribute vector math here, and we can plug in after the point distributes. And what we're trying to do is we're trying to get the distance between this empty object and all these points here, and then use that distance to drive the scale of the points. And for that, we obviously need the location of the empty object, and we can get that from the input object info node. So we can just add that here, and we'll specify the empty object from here. And so now we have access to the location of that object. And then in this attribute vector math node, we will compare the point's position to the location of this empty. And right now our B input is an attribute, so we can change that to be a vector here. And then we can just plug this object location straight into the B input there. And now we are adding them together. And of course we want to get the distance between them. And then we will write that distance down to a new attribute called distance as a result of this vector math operation. This distance attribute is now a float, so we can actually already use the float to drive the scale of the points. So if we add an attribute math node here, we can multiply the scale attribute by the distance attribute like this, and then we can map the result back to the scale attribute. But right now you can't see anything. There's this weird feature or a bug, I guess. I don't know if it's a bug or a feature where you need to sort of fill in the scale attribute before you do any math operations. So we can add an attribute fill node here of a float type, and we can manually fill in the value of 1. It somehow gets initialized back to 0 with these math operations if you don't manually fill in the value beforehand, even though it seemingly already had the value of 1 before we added the math node. But anyway, now you can see that we have some action here. So the further away the sphere is from the points, the bigger the points, because the bigger the distance. So the effect is kind of the wrong way around, and it's also not clamped. So if I bring this really far, the points just get bigger and bigger without any bounds. So we need to clamp the values between 1 and 0, and also we need to reverse the direction. Oh, and I also noticed that we have a mistake here. As you can see, these points never get to the scale of 0, even though this empty is really close to them. And if I bring the empty down towards the center of the scene, the points do get to the value of 0 also. So that tells me that this object info node here is in the wrong mode. It needs to be in the relative mode. So now it knows to correctly account for the relative positions between these objects, and now it works like it should. So we can do both the reversing and the clamping with one node, and it'll go in the middle of the distance calculation here and the scale multiplication here. And the node is going to be attribute color ramp here, and we can just put it there. So what this node does is it takes a float attribute. In this case, we're going to feed it the distance one, and it sort of remaps the float values based on this color ramp here. So on the left side, it takes everything that's 0 or less, and it clamps it into this color value here, which is black currently, which equals to 0. And on the right side, it'll take everything that's 1 or bigger, and clamp it to this color value here, which is white currently, which equals to a value of 1. And we can also change the interpolation from linear to ease, for example, to make the transition a bit smoother. So if we now feed it this distance attribute that we created earlier, and we also map the result to the same distance attribute, we should now see that the values are clamped between 1 and 0. So even if I bring this empty really far away, the points never get bigger than 1. So now they are clamped, and we can also do the reversing just by simply reversing the order of these colors here, like this. And now we are actually pretty close to the effect we are after. So the points disappear when the empty gets far away, and they appear when the empty is closer. The only thing we need to do now is to increase the sort of the radius of the effect a little bit, because I want the effect to cover sort of the entire monkey when the empty is here in the middle. And we can increase the radius by sort of fooling geometry nodes to think that the distance between the empty and the points is actually smaller than it really is. So if we add another attribute math node here, after we have calculated the distance, but before we feed it to the color ramp. So we have a math node here, and it'll be a divide operation. We are dividing the distance attribute with a float, which will be 2, and we map the result back to the distance attribute. So now you can see that the effect is bigger. It covers most of the monkey when I'm here in the middle, which is what I want. And this value here, this dividing value, has essentially become our fall of distance value. So the bigger the dividing value, the bigger the radius of the effect. So you can think of it like if the distance between this empty here and the points somewhere around here would have been 1 unit before the dividing. It's now divided by 2 and the distance becomes 0.5. And down here somewhere at the bottom, it would have been 2 units before, and now we divide it by 2 and it becomes 1. And then we feed it to the clamping color ramp here. So we can sort of modify these attributes after they have been created with simple math operations. And yeah, this part of the effect is pretty much complete. I'll maybe decrease the minimum distance just a tiny bit, because they could be even more tightly packed. Maybe 0.04 would be good. Yeah, I think that's better. So the only thing that's remaining is the other part of the effect, which were these vertical streaks. And to make them, we're going to use much of the same principles. So I'm going to try to speed through them a bit quicker this time. So first things first, we're going to make the streak object itself. We're going to add a cube. And let's make it thinner like this. Add a loop cut. Make this part really small. This part really small also. Add another loop cut here and there. Scale these down like this. Add some smoothness. And then make the whole thing even thinner and a lot smaller. Something like this, maybe. We're gonna try that out and see how it looks. Let's name this streak. And back to the nodes. What I'm gonna do is I'm gonna make some space here. And I'm gonna Control J to make a frame for these, because that's our first effect. And we're going to preview this new effect by just plugging the geometry straight to the output. And then we're going to add another point distribute node, just like in the beginning. Poisson disk, 0.04. Max density can be 1000. Now we have a nice set of points there. And then we'll add the point instance node. Choose the streak object there. And the points take the normal from the mesh. So we need to modify the rotation attribute. So we're just going to add another attribute fill node, plug it here, vector, rotation, and then you can just eyeball a suitable amount of rotation. Something like that looks good to me. The streaks might need to be a little bit bigger, so I'll just scale them up a bit. And then we can add yet another join geometry node to join this effect with the old one, so that we can see both of them at the same time. I will also randomize the position of the streaks just a bit so that it doesn't end so abruptly here at the sides. So I'll just add an attribute randomize node from here. We're going to randomize a vector. We'll call it pos2, and it'll be a vector from -1 to 1. And then we can add an attribute mix node, and we're going to mix two attributes, position, pos2, and the result will be on position, and the mix mode will be add. Factor to 0, and then we can dial in a suitable amount here, maybe 0.07. Yeah, that looks good. And then we need to make the controller fall off, and we can just take these 4 nodes here, Control G to make a node group, and we can take this fall off distance also as an input. Let's name these fall off distance, and this will be controller location like this, and this can be called distance fall off like this. So we've simplified the overall setup quite a bit, and then we can just call the node group from here, plug it here, and then let's take this out of the group from there and feed that location to there also. And then we also forgot to do the scale attribute filling before we do the math with the scale. So we can just fill the attribute here at the beginning. And now we have a nice fall off on the streaks also. In the original setup, I also had a cloud texture sort of randomizing the scale of the streaks. So if you want to do that, you can just do it before the distance fall off thing in this space. So we're going to add an attribute sample texture node from here and create a new texture. Let's call it clouds. And the mapping will be the UV map that we already have on Suzanne, which is called UV map. So we'll type that here, and we want to map the texture to the scale attribute of the streaks. And then we need to actually make the texture here. So let's select the clouds texture from here. It automatically made it for us. And then choose clouds and maybe increase the size and decrease the depth to 0 to make it more smooth. Now you can see that the streaks are being affected by the cloud texture. But right now it's pretty static. It doesn't move around like in the original example. So what we can do is we can manipulate the UV coordinates in geometry nodes. And to do that, we're going to use an attribute vector math node. And we can take the UV map and we can add a vector to it and then replace the original UV map. And for the vector, we can obviously use this controller object's location. And so now if I move this controller around, you can see that the cloud texture is moving along with the controller, which creates this nice animated effect. We kind of don't want the streaks to scale all the way to 0, however, so we're going to enable this color ramp from the bottom here. So here we can maybe bring this white value up just a tiny bit and then increase the black to somewhere around here so that the streaks never go to 0. So now you can see that we're pretty much done with the effect. The only thing we need to do now is to make a basic lighting setup here. So real quick, just enable rendering mode and let's make a material for the Suzanne. It'll be dark gray like we had in the original. This cube can be the same color. The world can be quite dark. The streak needs to be bright and also transparent. So we can do that here. Let's add some emission to it. Maybe something like this. Emission strength can be 5. Blend mode, alpha blend. Shadow mode, none. Alpha 0.01. Something like this. And then for the torus, we can make something even brighter. Let's have a nice color first. Emission strength 5. And then again, alpha blend, none. Alpha can be like 0.5 or something. And then just enable ambient occlusion with a distance of 1. bloom, increase the threshold just a bit. Something like that. And now we can, let's say, make this lamp a bit bigger and enable soft shadows from here. Increase the cube size. I could make an EV lighting tutorial sometime if you guys are interested. These are simple things, but they add a lot to the scene when you think just a tiny bit about the lighting and different things regarding the rendering. And now you can see that we are done with the effect and it looks very nice. I hope you enjoyed this tutorial and found it useful. I've been following the Gamestop stock thing a little bit recently. On social media, there's a lot of people hyping each other up, and they're hyping each other up to be angry at the hedge funds and at the brokerages that are limiting trading, etc., etc. A lot of people are talking about how we have the right to be angry, and we should be angry, and let's use the anger to do good, productive things. And I'm like, I'm not really sure about that. I'm not really sure if that's a good idea. It's a very double-edged sword to use negative emotions to try to do good things. On one hand, emotions do provide a lot of potential usable energy when it's channeled correctly. And on the other hand, there's a huge chance of emotion-induced blindness, essentially. You need to be on top of your emotions to be able to use them rationally as a tool without any major risks of things going south. It's very easy to jump on an emotional bandwagon and lose just that little bit of calmness and rationality that would have otherwise prevented an outrage about something. Let's say the outrage about Robinhood halting the purchasing of stocks of GME or something. Now, I'm not saying Robinhood did nothing wrong. We don't know all the details, at least I don't. I'm just saying that there was a huge emotional, angry rage about Robinhood being the bad guys and intentionally manipulating the market. And then a couple days later, there comes out a new piece of information about how they had to do it because they would have crashed otherwise, because they didn't have enough funds to sustain that trading volume or something. I don't understand the details very well. So again, I'm not taking sides on the Robinhood thing or the GameStop thing or anything. They might have done something wrong and illegal, and there needs to be an investigation, and they might also need a better PR person. But the thing is that when reading the responses from when people first found out that the trading is limited, there's a lot of hate and there's a lot of certainty about the reasons for the hate, and there's not a lot of consideration of some other possibilities. And that's what seems dangerous to me. And it seems to me like that was because of the anger and because of all those negative emotions and those bandwagons and all the hyping and that sort of stuff. It just feels to me very clear that it'd be better for everyone to not go to the web like emotions are fine. They are a part of the human experience. But in social media where there's these huge viral phenomena, I don't think it's a good idea to go out there and rile each other up, especially with these mostly negative cases. I think that some generally more positive or wholesome cases might have a little less chance of going really south. But even they can if there's a lot of wrong information or a lot of emotional blindness going on. But especially with these negative things where the whole setup is pretty negative from the get-go. Wanting revenge for someone or something is a pretty dangerous thing, in my opinion. It's a part of our more animalistic side, a part of our darker history, if you will. Like, at least in European history, there was first stonings, and then people were like, okay, let's not have everybody stone the bad guys, but we will crucify them and you can watch. And then they were like, okay, it's a bit of a long and painful process, the crucifixion, then, but we'll hang them and you can come watch, you can have a picnic and we'll hang the bad guy. And then they're like, okay, but that's not really a nice thing to do, to have a public hanging like that. We will do non-public executions. So you can't come to watch, but they will get punished and they will get executed. And we as a civilization are slowly trying to move away from that kind of revenge. And nowadays, a jail sentence is a more common way of getting that revenge. And that's why I think these viral, negative, emotional roller coasters are a bit of a dangerous territory. They cater to this dark part of our human experience and the human mind. So in conclusion, yeah, I do think that something shady might have gone down with these hedge funds and the shortings, and the aggressive shorting itself is unethical, and we need to have the discussions about them. We need to have investigations. We need to have political discourse about it, and we need to maybe make some new regulations or something, and all these things. But I don't think getting so angry about it is a good way to go towards a better system. I've learned a couple of things about my anger and my emotions that I feel like might be worth sharing. First of all, whenever I feel like I'm 100% sure about something, usually I'm wrong. There's always more to it. There's always shades of gray. And I treat that certainty as a warning sign that there is too much emotions involved. It's happening less and less nowadays. I'm less and less 100% sure about anything. And there's a lot of gray in the world to me. And I think that's a good thing. I don't think people should be 100% sure about, I won't say anything, but it's pretty close to that, at least. And secondly, when I do get angry about something, continuing to be angry about it for a long time has never been a good idea for me. It's always been better to calm down and take a break and collect myself and collect my thoughts, collect my emotions, and let the emotions come, and then feel them and let them also go away a little bit, and then start to tackle the thing. That's proved to be the best way to work for me pretty much always. Whenever I feel like I'm almost happy to be angry, like it feels good in some way, that's when I know that I'm listening to a wrong part of myself, that I need to calm down and collect myself. That kind of angriness leads to bitterness and sadness and sustained negativity, which just makes you sad and miserable. I just like being positive and optimistic, or at least neutral, more than getting angry about things all the time. Anyway, I hope you found some of this useful or interesting. I hope you have a great day. I hope you feel good and peaceful. And if you don't, I hope you can find your inner peace and continue finding it. I at least get to work on it all the time. You know, the sun will rise tomorrow, the sea level will rise tomorrow, the global temperature will rise tomorrow. We are having a good time here. But jokes aside, thanks for watching, and I'll see you later.